Hello explorers and welcome to another video. Today I'm gonna talk a little bit more about HearthStone and this HearthStone project. We are trying to create a lot of different small tools in order to take ourselves that we are trying to get from a deck that we own and the metadata about that deck and find what kind of decks we can build with our own cards. In my example here, I have a database with about 200,000 decks or something. And now I need to take all those decks and compare them to my deck and see if I have all the cards needed to do that deck. So this program starts with creating a list of the cards I own and how many of those cards I own. So the cards I own I will store in a hash map. So I will have the name of the cards and how many cards I have of that name. In HearthStone you can have one or more of one card and you can play with a deck of 2 of each card. So I need to have a hash map with the amount of owned cards in order to build my decks. Then I open my database with all my cards that I have clicked through and actually added how many of each card that I own. So this is pretty straightforward. I open the DB-JSON. I get the array of cards. I iterate over the array, check how many I own. If I own more than 0 cards of that name, I will put them into my hash map. The next piece of code I wanted to write was to ensure that I don't have any duplicates. So I start by creating scene keys. Then I fetch the arrays of all the decks that I have found previously. And if the old decks array that I fetch from decks are empty, which means that I don't have any decks yet, I will create an empty array. Then I will go through the old list of cards and pick each deck and send the SHA key of that deck into my scene keys. So I will create a SHA of each deck of cards in order to ensure that I have unique decks in my list. Then we start with the fun part. Here we parse the decks JSON, which has all the decks that I have gathered. So my 200,000, 100,000 decks, or how many decks I have gathered. I create an array of those and iterate through the array. I have an array that I call the clean list of cards, and that's after I have removed all the duplicates of cards that I have in my data. So my data isn't clean, so I will clean them up and create a clean list of cards that I can use for my deck. Then I create this list of scene cards, so I don't have any duplicates of cards in my decks. And I go through each deck. So I will create a JSON object for each deck and I will fetch all the cards as an array. And here I will enumerate over the cards and fetch the name and the amount of the card. I will check that I haven't seen this card before in this deck, and if I have, I will skip over it and try the next step in the loop. Otherwise I will add it to my scene cards and then add the card to my clean list of cards. Next I will check how many of this card I own, and I will check if I own more than the amount that is required for this deck, or if I don't, I will add as many as is needed for this deck. So pretty much here I will add the amount that a deck require. So if the deck, for instance, require 1 card and I own 2, then I will add 1 amount of that card. And if not, they are probably equal. So then I will add my own amount instead. So if the amount is 1 and if the amount is 2 and I have 2, then I will add 2. halfway! Now we have iterated over all the cards and created a clean list of cards. And if I have more than 29 cards in my deck, I know that this deck is a full deck, because then I will have at least 30 cards in my deck, so it can be used. I will create a hash for the cards, this clean list, and if I haven't seen that hash before, I will increment the deck count. I will put the cards into my current deck that I'm working with. I will add the SHA key to the deck, and I will also add the key to the scene keys. The next row is some debug output, so I will see how many decks that I create during creation. This part can seem a little bit strange, but this is for debugging purposes. So for instance, if you want to test to run a few decks and then stop at the deck created number 10, and then print all the cards in that deck and the name and class and so on, you can do this and then abort the operation. And I have done that when I actually got a deck which didn't make sense. It was too many cards, too few cards, and so on. So this was used during development. Not required, but I kept it for you to be able to debug the code if you like. Now that I created unique decks that I can build, I will write them back to the database JSON at decks and add them back to the DB JSON that I use in my web application to both click decks and show deck listings. Now I've pretty much gone through all the code that I've written so far, but I have one part left, and that's the hashing function. And the hashing function I use to check that I actually have a unique set of cards. So if we remember up here, we have this get hash and this key. I will look into the scene key, so I haven't seen this key before. So this is crucial to get unique decks in your list. This hashing function is also pretty straightforward. I create a list of card strings by iterating over the cards and adding a string with the number of cards first and the name of the card second, lowercase. And then I take this string list and sort all the strings, and that's important in order to ensure that you actually get the same hash, because if you have a different order, you might not end up by the same result. A message digest, which is a hashing function, works that you have some state that you start with, and then you add data to that state in order to change the value. And if you just add 1 byte, you will change the output data completely. So in order to ensure that we get the same result every time for our card strings, we need them lowercase and we need them sorted, so they come in the same order each time and the same capitalization. Then we create a message digest instance of SHA-1. SHA-1 should be sufficient here because we are just checking that we have the same data. I iterate through my card strings and add the bytes for each of these strings to the update function. And when I've updated my message digest with all the strings, I will return the base 64 encoded string of that digest. So this is a way that you can take a huge set of data and gather them down, create a unique set of new data that you compare with something that you already own. In the next part of this series, I will continue with the web application and present the decks of this application, and later in the series we will make them searchable and create categories for them and so on. So if you want to see more videos of this series, please subscribe to the channel. If you have any questions at all, then post them in the comment section below. If you like these kind of videos and want to see more of them. And if you have any good ideas what you want me to tackle next, please tell me. I'm all open for suggestions. I hope that you learned something today, and I really hope to see you in the next video.